Hello everyone, and welcome to the lab video for our Potato Osmosis Lab. So the materials you're going to need a potato, and you're going to need a knife, and you're going to need to slice that potato into 9 equal-sized bricks. In the lab protocol I say make them about the size of your typical 2x4 8-prong, your 8-pronged Lego piece, about the size of a Lego piece. It's not really that important as long as they are all the same size. So you want them to all be very uniform in size, and mine aren't even really the size of a Lego brick. They are smaller than that probably, but you want them to be uniform in size, and you want them to be able to fit 3 submerged in 100 milliliters of solution that you're going to prepare. So the first thing you're going to need to do is you're going to need to prepare your 3 solutions. So you'll need 3 different cups. Now I have 3 clear cups that are kind of like sample collection cups. You can use some plastic cups from the dollar store. You can use glass cups from your cabinet. It doesn't matter. You want them to be small enough though, so that, and they don't actually even have to be the same exact size. It's better if they are. But they need to be able to hold 100 milliliters and have your potato pieces be completely submerged in them. So the pool of water needs to be deep enough that your 3 potatoes can fit in there. And that's the important thing. So the instructions say to measure out 100 milliliters of water for each of these cups. And so you're going to use your 100 milliliter graduated cylinder. And when we read the graduated cylinder, we want the line to be exactly at the 100 milliliter mark when we are eye level with it. So it's not quite 100 milliliters. You might use your dropper to get it there, or you might be able to pour it. This is just tap water that I've put in a water bottle for easy pouring. All right, so I'm going to add 100 milliliters to each of these containers. I have them in backwards order, don't I? A, B, C, that feels better to me. Now A is just going to stay pure water, but B and C are going to be salt solutions. So we're also going to need to add salt. All right, so for adding the salt, I'm just going to put these over here for now so you can see what I'm doing. We're going to use our scale to measure out the correct mass of salt. So it's helpful to have a piece of paper, or you could use like a little cup. Doesn't matter. Just have something to put on here that you can put the salt on and then use to transfer the salt into the correct tube. So I'm going to put the paper on here right now and turn it on. Actually, technically, I should turn on the scale, wait for it to say 0, then I'm going to put the paper on it, and it's going to show weight of the paper, the mass of the paper, and I'm going to hit T to tear it back to 0 so that it's negating the mass of that paper. You'll want maybe a spoon or something to help scoop out the salt, or you might just pour directly. So the first one, it says add 0.9 grams, 0.90 grams. I'll pour it into the spoon here and then add it to my paper slowly. Oops, and I did a little too much. So I have a little waste container over here. I'm just going to scoop some of it off. You don't want to put it back in the salt container. Scooping some of it off here. I went overboard. And at 1, okay, I'm going to just kind of pour some of it off into this waste container. Trying hard not to spill my salt and keep it on the paper. I am at 0.87. So I want it to be at exactly 0.9. So I'm just going to add. Chemists are very exacting practitioners. They're bakers, not cooks. They have to get get everything exactly right. All right, I'm at 0.90. So I'm going to put that in cup B. Boop. And I will need to stir that up, which I'll do in a moment after I add 5 grams to C. So let's measure out 5 grams. I am going to pour this directly on here. 2, 3, 4.3, and now I'll add some to my spoon so I can add it more slowly. Till I get exactly 5, and it's super boring to watch. Speed up the video. I can't talk and do it. Oh, perfect. Exactly 5.0 to my waste container and into cup C. All right, so A is just water, pure solvent. B, we have solvent and solute. We're making a solution here, stirring it up until it's completely dissolved. And then C, stirring that up until it's completely dissolved. And it might take a little bit longer. It helps actually if you use warm water. It will dissolve a little bit faster because solutes dissolve faster. Solid solutes, like salt, dissolve faster in warmer solvents. All right, I think that is actually, I'm not hearing any more grit, and I think it'll be a little bit cloudier than the others. All right, so I have those prepared. I've already cut up my potatoes and have those prepared. I do need to weigh these. So what I also have are 3 little trays that I made just out of saran wrap. I have like plastic trays and stuff I can use in the lab, but I wanted to be more realistic to what you have at home. So you could use foil, you can use saran wrap. It just can't be paper. It needs to be something non-absorbent that won't absorb water. We want it to be sort of water resistant. So I just took some saran wrap and I just folded it a bunch of times to make these little trays. And so I'm just going to put 3 potatoes on each one. All right, so now I have my A potatoes, my B potatoes, and my C potatoes. So I'm going to need to weigh each of these. I need to tare my scale because looking at my scale right now, it says negative 0.71. So I need to hit the T button to make it go 0 again. And then I will put this whole thing on the scale. All right, try not to make the tray hang over the edge too much. You want to make sure the tray is about the same size as the weigh pan, or otherwise you won't get accurate weight. So make sure you fold the saran wrap tray to be small enough and that your potato blocks are small enough to fit. All right, so I would record the weight of potatoes A. I'm going to put those here in front of cup A. I would then put the tray of B potatoes on. I would record the mass of that. And then I will do the mass of this C group of potatoes. All right, and I would record all of those in my data table. Those are my starting or initial weights. All right, and what we are looking for is to see if the weight changes after soaking them in these different fluids. So in osmosis, all right, if the solution is isotonic, so it has the same concentration of solute as the potato cells, then water will flow in and it will flow out at the same rate, and there will be no change in weight of the potato because no water is being absorbed or lost. It's a net even, right? If it's hypotonic, the solution is less concentrated than the potato cells, then water will move into the potato cells because water follows solute and the potato cells are more concentrated than a hypotonic solution, and the water will build up in the cells and the cells will gain water weight. The potatoes will gain water weight. If the solution is hypertonic, so the solution has a higher solute concentration than those in the potato cells, water will leave the potato cells. It will lose water weight. All right, and so we will be able to see that. We won't be able to see it with our eyes. The changes are not going to be that dramatic, but we will be able to see it on the scale. So now I'm just going to transfer my 3 potatoes, group A potatoes, and I'm going to separate them. I want to try to get a good surface area for each of them in the water. I'm going to transfer them to A, transfer the B potatoes to cup B, and transfer the C potatoes to cup C. Boom, boom, boom. And now I'm going to wait an hour. I'm going to walk away, do some chores. Again, it doesn't matter what size your cups are as long as those potatoes, or the size of your potatoes really, as long as the potatoes are the same size and as long as they are fully immersed in each solution. That the cup is big enough to hold 100 milliliters and that it's small enough that 100 milliliters is deep enough to submerge your potatoes in. Okay, so put these aside. Oh, it's been an hour. Come back. 45 minutes, I think, actually. 45 minutes. You come back, and now it's time to reweigh these. So we're going to remove them from solution, and we're just going to blot them on a piece of paper towel because they will be soaking wet. All right. It might be helpful if you have some tweezers. Actually, a spoon works nice to fish them out. So fish out your potatoes from A. Put them on the paper towel. This is just to soak up any excess water, right? We just don't want to count the water that's on the outside of the potatoes. So I would just sort of roll them around on the surface of this paper towel a little bit to just get that excess water off. We want to measure how much water was absorbed into the cells. So got the excess water off. They're not visibly wet. And I'm going to put them back on tray A. I'm going to do the same thing for the potatoes from solution B. Take them out, scoop them out with a spoon right onto a paper towel. All right, and kind of roll them around to blot them dry a little bit, just to get that excess water off, and put them back on tray B. It's important that you keep the same potatoes with the same tray because that's the tray you weighed it with, and the trays might weigh different things. So it's important that you label the trays and that the correct potatoes go on the correct tray. And now for group C. All right, and just gonna kind of just roll them a little bit in the paper towel here. Just visually looking at them to see that they're not soaking wet on the outside. They don't have excess water. You might need another paper towel. This one's getting pretty saturated. All right, and put them back on tray C. And your scale might have turned off at this point, so you can turn it back on. Wait till it reads 0. If it doesn't read 0, you hit the T button, the tare button, to get it to 0. And then again, you're going to weigh tray A. Wait for it to steady out and record the exact weight that you see. Make sure you're in units of grams, by the way. And then do the same for B and the same for C. So one of these sets of potatoes will have gained weight, another will have lost weight, and the third one, hopefully, its weight didn't change, or it didn't change that much. It might have changed a little bit, because I'm not exactly sure the concentration of sodium chloride in these potatoes. And it might be different depending on which type of potato you use. And you can use any type of potato. That's fine. Doesn't have to think this is a local potato. It's like a baking potato, like a russet potato probably. But you can use a red potato, white potato, yellow, just a potato that you can cut into small blocks, okay? So then you will be doing the calculations to determine which one of these, which one gained weight, which one lost weight, and that will help you determine which one of these solutions was hypotonic, hypertonic, or isotonic. And of course, I want you to explain, when you're explaining which is which, using that CER, the claim evidence reasoning process. So if you say that solution F, I'm just using something that we don't have, a hypothetical, okay, that solution F is isotonic, okay, that's your claim. What is your evidence? What did you observe in your data that suggested that that was the case? Well, isotonic shouldn't change weight or shouldn't change very much because the water moving in and is moving in and out at the same time. So your evidence is that the weight didn't change that much, and your reasoning is that isotonic means that water moves in and moves out at the same rate. Therefore, in an isotonic solution, the weight wouldn't change much. So you're giving a complete answer. You're backing it up with evidence, and you're backing it up with scientific reasoning. And that's important in science, that we communicate clearly. It's also important in criminal justice, in law, that you are not just accusing someone of a crime, but that you are also providing evidence and motive, rationale. So in making complete arguments in any field, those are sort of the three-step process that you want to take. So when you are done, all of these solutions can go down the drain. They're just salt solutions, and the potatoes and trays can go in the trash. Please don't eat the potatoes that you used for science. And that's all I have for this lab. Enjoy.